In this video, we're going to be looking at the comparison between two system monitoring tools, top and htop. These two text-based tools are commonly used to keep track of processes on a system. And at this point, you may be asking yourself, why bother with text-based tools if I can have graphical user interface tools like System Monitor? Well, there are many reasons why these text-based tools are still used. So for example, if you remote into a server over the network and you're not able to launch a GUI, then this may be your only game in town. In some cases, some people prefer to use only a keyboard because using a mouse slows them down. And I know there are some system monitors out there like htop, btop, gtop, vtop. Basically any letter you place in front of the word top may probably exist. But top is still very popular because it's pretty much already installed in almost every distro by default. And then htop is probably the most common alternative. So why and when would you use a system monitor? Well, at times you may have a slow system and you want to understand why. You can use a system monitor to see what processes are using up the CPUs or the memory. Or you could be chasing down a rogue or stuck process that you want to get rid of. Other things you may want to do with a system monitor include searching for a process by name, filtering for specific user tasks, or changing the way that the system prioritizes your jobs. Let's take a look at our first tool today called top. Top has been around for a long time, and it's also included in pretty much all the distros I've ever used. So really, there is no install necessary. To run it, just type top, T-O-P, on the command line. So what we see here is essentially two blocks of information. On the upper portion of the screen, we see the summary info of the system in terms of the uptime, which is the amount of time the system has been on, the number of users logged in, and the load average over the last 1, 5, and 15 minutes. So in my system right now, you can see that this machine has been up for about 11 days, 5 hours, 2 minutes. I have 2 users logged in, and the 1 minute load average is about 4 point something. The second line is the information on running tasks. So it gives us the total tasks that are running in the system, the number of them that are running, the number of them sleeping, stopped tasks, and then zombie tasks. So my system has 200 plus tasks in total, but it's really only running 2 of them right now with the others sleeping. And this is fairly typical, right? If you have too many jobs running, then your machine's going to be pretty slow. I also have 1 stop job and no zombie tasks. Now I know which job I have that is stopped, so if I continue that job, the status will now reflect that I no longer have a stop job, and the running jobs will change to 3. The third line here is the CPU usage, which tells us the amount of time that it's spent running user processes, the amount of time spent running system processes, the time spent running NICE processes, kernel idle handler, time waiting for I/O, time spent servicing hardware interrupts, time spent servicing software interrupts, and then time stolen by the hypervisor from this particular machine. So this is going to contain some pretty heavy concepts that we'll visit separately, but for the most part, it just tells us how much the CPU is being used. My system is telling me that within the last refresh interval, which is 3 seconds by default, my user task had run for about 70% of the time, while the system had used about 16 to 17% of the CPU. And the other categories are pretty much 0. The fourth line is the memory usage, listed as total amount of memory on my system, the free memory, the used memory, and then any memory that is buffered and cached. So my example here, I have 4 gigs of physical RAM in this machine. And so we see that about half of that is free and available for usage, and about half of the 4 gigs is used by the system. The fifth line here is the swap usage info, or virtual memory usage, and it's listed similarly as the total amount, the free amount, and used amount. And the last field here, named available, is the amount of memory that is available to start new applications without having to swap. The bottom block of information on the screen is the process table, which shows all of the processes running on this machine. This list can be quite long, as you can see that we have over 200 tasks running on this system. To see the other tasks, you can use the up and down arrows to go through the list. But keep in mind that every 3 seconds, the list will refresh, so this could be confusing. So you may want to change the refresh duration to longer than 3 seconds if you want to scroll through the list and not have the information change on you. So to change the refresh interval, go ahead and type the letter D for duration, and then the number of seconds between refresh. So like I said, the default is 3, but you can change it to 10 or 5 or whatever number you want. And you can use decimals or fractions of a second. The default display columns are PID for process ID, user for the name of the user that started that process, PR is the priority of that process, and I is the nice value of that process. So this goes between -19 to 20. With the higher the number, the nicer you are, which means you're going to let other processes have priority over you. 0 means don't make any priority adjustments, and that's the default. VIRT is the total amount of virtual memory used by that task. RES is the resident memory size or the non-swapped physical memory a task is currently using. SHR is the shared memory size. The S column tells you the process status. So the common letters here are R for running, S for sleeping, I for idle, T for stopped, and Z for zombie. Next column is %CPU. So this tells you the percentage of the CPU that a process has used up within the last refresh period. And as you can see here, the percentage actually goes over 100%, which may not make sense until you realize that the percentage is basically over the number of CPUs you have. So in this case, I have 4 CPUs. So really, the maximum is 400% instead of what you think of 100%. I know, it's confusing. All right, next is the %mem. So this is what the task is currently using in terms of the percentage of resident memory. The second to last column here is time. So this is the total CPU time that the task has used since it started. And the last column is command, which is the name of the running program. And you can hit the letter C to see actually the entire command line of that task, not just the program name. And when we're done with the top command, you can just hit the letter Q to quit out of the program. Now let's take a look at the other popular system monitor, which is htop. Htop is probably not installed by default on your distro, so in order to do so, I'm going to do sudo apt update && apt upgrade. And then after that, I'm going to do sudo apt install htop. And basically this is for my Ubuntu and Debian build. If you are running on Fedora or Red Hat or CentOS, you can use dnf install htop instead. Right, to run the program, just type htop, H-T-O-P. And the first thing you notice is the fancy colors, which makes it visually easier to identify areas of interest. Another thing you will notice is that the output is similar to top in that the system information is the upper area of the screen and the process table is at the bottom portion of the screen. You will also notice that by default, htop is made for multiple CPUs and cores. So it's already split up the 4 CPUs that we have, and then it's also displaying it as a bar graph as opposed to raw numbers. And if you try using the mouse, you will notice that you can scroll and select specific tasks. You can also click on a column header to sort by the column. You can click in succession to toggle between ascending or descending sort. You can also click on the menu items on the bottom or use the associated function key on your keyboard. So for example, if you click on the word help or use the F1 key, you will get the help menu. And when you're done, you can hit the escape key to get back to the htop main screen. The setup menu or F2 key will allow you to modify the display options, the meters, the header layout, etc. And when you're done with this screen, you can hit F10 or click on the done. Hitting the F3 key or selecting the search function will allow you to look for a task with a specific name. So if I type DD, The first process that contains the word DD will be highlighted and will remain on the screen as the task update. And I can hit the escape key to clear out the search field and return to the main screen. Hitting the F4 key or selecting the filter function will allow you to only show processes that match the string you type. For this example, I'm going to type DD again. And this time we see the DD job at the top of the list. And then we see a few other tasks that have the sequence DD on the command line somewhere. Notice that we don't see any other tasks that do not have the pattern DD, right? So this is really filtering out everything else. And so this is the distinction between a search and a filter, where searches gives you the result that you're looking for along with everything else, but the filter only gives you what the filter can see. And when I'm done with all this, I can hit the escape key to clear the filter and return to the main menu. All right, hitting the F5 key or selecting the tree function will switch back and forth between the tree view and the list view. The tree view displays all the threads spawned by a certain command. So here I am in the tree view, and you can see these vertical and horizontal lines which denote the parent and child processes. If I use my mouse or arrow keys to get to the top where the PID number 1 is listed, we can see that's the system D process. And so system D is the first process in my Linux system that spawns all of the other processes that run the system. And we can see that if I use my mouse to scroll down the list, I can see the terminal process, which has a child bash process, which in turn has a child DD process that I started. Hitting the F6 key or the sort by function will allow you to choose which columns to sort by. So you can see that in my display, I have the choice to sort by PID, by username, priority, the nice level, etc. And you can use your mouse or keyboard to highlight the field that you want, and then hit enter to sort by that field. So I'm going to go ahead and select the memory percentage. So notice that the memory percentage column is now highlighted and has the triangle pointing down, indicating that it is a descending sort. And you can click on that field name and reverse the triangle to sort in ascending order. Make sure that you are in list view if you want to know which processes are really the highest in terms of using up that particular resource, as viewing in the tree view could be a little misleading. All right, F7 and F8 are the functions that allow you to change the nice values of a process, thereby affecting its priority to be executed with respect to other processes. We're not going to mess around with the nice values today. We're going to leave that for another video. And if you hit the F9 key or the kill function, it will bring up the menu that allows you to pick the signal of the kill command to send the process that you had selected before. Right, so basically you select a process first and then you click on the kill and it will kill just that process. And then once you get there, you hit enter to send that signal, or you can hit escape to get back to the main htop screen. After seeing the two tools, you probably see some obvious differences between them, with htop being more user-friendly right off the bat. But if you're a big fan of top and can't download htop to your system for whatever reason, or if you don't want to learn something new, here are some ways to mimic the things that you may like about htop and perform them with regular top. The first thing is color. It's obvious that htop by default is more colorful, but we can change that by hitting the Z key or Z key, and this will toggle between the monochrome mode and the color mode. Right, so these colors will depend on your terminal color settings, and some will look better than others. And you can kind of play around with that in the profile of your terminal window and see which one you like more. The second thing you can do is to toggle between showing the aggregate CPU, which is the default on top, to showing individual CPUs, which is the default on htop. So all you have to do is hit the number 1 key to toggle back and forth. Right? This will show you between the aggregate CPUs and then all of the CPUs, which in my case is 4. So the third thing we're going to do is we're going to change the CPU usage from a numerical display to a more graphical display. So what I'm going to do is hit the T key for toggle, and what this is going to do is put the CPU display through a 4-way toggle. So the first one is going to be the default, which is the CPU usage in numbers. And then if I hit the letter T, it is now going to show the user/system usage as a percent. And then the third number here is also going to be a percent of the total of the first two numbers added up. And then it's going to have a graphical display for the CPU. And if you hit the letter T again, it is going to stick with the user and system usage in a percentage, but then now it's going to go to a block graph, right? So this might be easier to see visually. And then if you hit the T again, it is going to give you the fourth display mode, which is not displaying the CPUs at all, right? And if you hit T again, it's going to go back to the first mode, which is displaying everything in a percentage. The fourth thing you can do is you can change the memory usage also into a graphical display. So here you can hit the M key for memory, and it will go through a similar four-way toggle that would display the memory usage in just numbers. Then if you hit M, it is going to show the percentage of memory used out of the total amount of memory, along with a bar graph. And if you hit M again, it is going to now change it into a block graph, but you're still going to have the percentages of usage for that particular resource. And hitting M again will basically go to the fourth mode, which is no display of memory at all. And if you hit M again, it's going to go back to the first one, which is just the numeric display of the percentage of memory usage. All right, the fifth thing we can do is we can change the command column here to go between the full command line with all of the dash options and arguments listed, or just the name of the program. So if you just hit the C key, it will toggle between the two different modes. Number 6, we can set the sort field of what we want to sort. And it'd be easier if you already have that column highlighted. And if you haven't already done so, you can hit the X key to highlight the sort column. And if the X key by itself did not work, you might want to set the bold reverse mode by clicking the B, the letter B for bold, so that you can see the highlighted column. Now you can use the greater than or less than keys to change the sort field. So I can basically do less than all the way over to the PID, and you can see that now I'm sorted by the PIDs. And because I was looking at the percent CPU before, now it looks like the PIDs are sorted in reverse order. So I can type capital R to reverse the sort and get it to sort by ascending order. And I can go ahead and use the greater than key to basically go and change the sorting column back to CPU percentage or memory or time or whatever I want. All right, the seventh thing we can do is we can search or locate a string, right? So this is the same thing as using the menus that was available in htop. And so I can type capital L to locate, and then I can type in the string that I want to find. So let's say I want to find the process DD. So now it gives me a bunch of commands that contain the word DD, but it may not be exactly what I'm looking for, right? Because some of these processes that has the word DD in it, but it's not really the DD command. So I can try that again with capital L and then DD space. And now the process that I was really interested in is highlighted, so I found what I wanted. Number 8, we can filter the process table so that it's only showing us what we want to see. So one thing we can filter by is the user, right? So type letter U for user, and then key in the username. So I'm going to type Blue Monkey Forensics. And so now we are only going to see processes from that user. And to reset this filter, we can type the letter U again. And as it says here, you can just hit enter without entering anything, and you will select all the users again. And we can also filter by a process name. So we can hit the letter O to get the other filter command. Now what we see here is a prompt that is going to ask you for a field name followed by a relationship. So it's either going to be an equal sign, a greater than, or less than. And basically the equal sign does not mean an exact match. It just means that the field just needs to contain the value that you're going to give it in the next bit here. And so in my example, I'm just going to type command equals DD. So it's going to basically look at this command field right here and look for anything that contains the string DD. And so you will see here that this will again include things that have nothing to do with the dd command, but just happen to have those two characters on the command line somewhere. But the thing you notice is that with the filter, you're not seeing all the other processes, just the ones that match my pattern. And I can type the letter O again for other filter, and I can add a second filter. But I'm not going to do that, so I'm just going to hit escape to get back. And now to clear the filter, I can type the equal sign, and then all filters will be cleared. All right, the ninth thing we can do to emulate what the htop things can do is to put ourselves in a tree view, otherwise known as forest view in top. So we can hit the capital V to toggle between list mode and forest mode. And instead of having vertical lines and horizontal lines that htop uses, in just top, it uses these indentions to denote child processes. All right, and the 10th thing that we can do to easily mimic htop is to figure out how to kill a process. And so to do that, you hit the letter K, and then you are going to be prompted for the PID of what you want to kill. It does give you a default PID, which seems to me like it uses the process that is currently using the most resources, right? So that's the logical thing to kill. And then once you hit enter on that or give it a PID, what it's going to do is ask you a second question on what signal you want to send to that process. And the default is 16. But usually when you have to actually kill something, I find that I just go straight to signal number 9. So anyhow, if you don't remember all the keys that we just talked about, you can always hit the question mark or H for help, and it will get you to the help window. So we took a look at two of the most common process monitors in Linux, top and htop. The newer htop is easier to use as it accepts input from a mouse as well as list out the common functions on the bottom for easy access. However, keep in mind that there are some circumstances where you may only have the top command. So make sure you brush up on the commonly used functions with that tool so that you can be just as effective using top as you are using htop. I know that you will enjoy another Linux forensics video like this one here. Click on the blue monkey to subscribe if the Pillsbury Doughboy is your role model. Thanks for your time and happy hunting.